Okay, thank you very much, Annetta. So once again, good morning, everyone, and thank you for attending today. I will be giving a presentation on CBE Plus to those of you who don't know us. And today in particular, we've chosen to give you a bit more detail about one of the processes that we carry out, which is electroless nickel plating. I'll be taking questions at the end of the presentation, and if you want to have a full screen view of the presentation, you can minimize the thumbnail on your right hand side, and you should be able to see the pictures and the charts on my presentation. So who are CBE Plus? We are a multidiscipline subcontractor based in Chesterfield. We bring together the capabilities of 4 legacy engineering brands who have a combined history of over 100 years. Our gear division was founded in 1890. The other 3 divisions were founded in the 70s and 80s. Marie and her business partner Chris Brown invested into the business in 2017. And we brought the 4 legacy brands together into one in 2019. In fact, some of you were here when we celebrated our getting together and the funding of CBE Plus. And 2021 will be the year where we physically relocate all the companies under one roof. I'll give you a little bit more detail about that later. So the 4 legacy brands and the 4 capabilities that we bring together are precision engineering, such as CNC milling and CNC turning, electroless nickel plating, which we will talk about in more detail later on today, gears and gears cutting, and finally metal testing on metals and the work that we carry out for our electroless nickel plating customers. And the idea and the vision behind CBE Plus is that we bring all these capabilities as a single supply chain for our customers. So just going to take you for a very brief overview of our factory. You can do this in your own time also on our website as and when you please. We have large milling capabilities. We have smaller milling capabilities, CNC turning, as you can see here. You can have a look at our apprentice cell. You can have a snoop around our gear division, and finally, you can take a look at the plans that we have for bringing the electroless nickel plating under one roof. So our plans currently are for this to take place by October this year. We'll relocate our legacy brand Nitec into the Enterprise Drive site, and to design a plating facility for the 21st century, we engaged the work of the AMRC, who've created this virtual reality tool for us, which, like I say, you can take a look at in your own time and see what our plans for the future are. So going back to my presentation, the sectors that we serve are aerospace and defense. We believe we are the only company in the country to be AS9100 accredited, both for CNC machining and electroless nickel plating. We're becoming more and more involved with the energy and renewable industries, in particular electric vehicles. Then a historical market of oil and gas is still going quite strong. We have customers in the rail sector, customers in the automotive sector, and as Jason mentioned, we were heavily involved with the Ventilator Challenge initiative in the summer, and we are exploring the medical devices sectors too. So, like I said, we're going to be talking about electroless nickel plating in more detail over everything else today. What is electroless nickel plating? It's a functional coating that is applied to parts, and we call it electroless because it's applied by chemical means as opposed to electrolytic or catalytic means. So a chemical reaction happens in the plating bath. It's a process that takes place at low temperature. So this is very gentle on highly engineered parts, for example. Instead of currents in the bath, like I said, the base metal itself acts as a catalyst, and the metal, in this case the nickel, is transferred from the solution onto the part that we want to surface treat. Because of the ways that this happens, then effectively it's fairly easy to set up special plating baths, which can be really almost unlimited in size. So here in this picture, you can see a production manager, Lee, and he's not a small man, but you can see the size of the part that we plated exceptionally for one of our customers. So we can treat a very wide array of materials. Obviously, the most common material we treat is steel. We can enhance the properties of mild steel and really create a product that is much better performing by applying electroless nickel. Aluminium, copper, and brass are also very common metals to treat, but we can also treat plastics and really quite exotic elements such as titanium, platinum, rhodium, and nickel itself. It's a very wide variety of surfaces that we can treat. So what is it that we're trying to achieve by electroless nickel plating? So there's three main properties that we can enhance: corrosion resistance, hardness, and wear resistance. Corrosion resistance is the main characteristics of electroless nickel. I'm going to refer back to let's call it a competitor surface treatment, which is a hard chrome, for one reason really. Hard chrome has been really popular within industry, within the aerospace industry also, for performing really well in these three characteristics I've talked about. Hard chrome is a pretty nasty process. Environmental entities around the world have been trying to phase it out for years. And what I'm going to try to present to you today is the fact that electroless nickel is almost off-the-shelf substitute to hard chrome. In some cases, actually provides a far superior performance. In terms of corrosion resistance, you can see that on this chart, we can greatly reduce the corrosion rate in microns per year by adding phosphorus to the plating bath. Above 10% of content in phosphorus, we really can reduce the corrosion rate to virtually nothing. The performance in this case is far superior to that of hard chrome. On corrosion resistant also, a test that is loved by the automotive industry in particular is the salt spray. A metal testing division has a salt spray test machine internally. Again, by adding phosphorus, we can push the fail mode of electroless plating to basically in excess of 1,000 hours, which makes it pointless to carry on any further. And by comparison, you can see the red dotted line is the failure mode of hard chrome. So in terms of corrosion resistance, EMP is far superior as a performance. Hardness is something that hard chrome is very popular for. Well, we can heat treat if the geometry and the specs of the component will allow it. We can increase the hardness of parts to effectively be competitive against the hard chrome. So on this chart, you can see the increase in hardness. The green dotted line is the hardness of nickel plating as plated. But with heat treating at 400 degrees, as you can see, we reach 1,050 vickers, which is comparable with that of hard chrome. Finally, we can increase the wear resistance of metal parts. Again, this is a function of the content of phosphorus in the plating bath. And once again, we seem to hit a sweet spot at 10% content of phosphorus, where EMP will basically perform the same way as a hard chrome. Further increases in the phosphorus content can actually push the performance a little bit further than that of our competitor surface treatment. So how is electroless nickel different to electroplating? Well, because the transfer of metal onto the surface happens by chemical means, as long as the component is immersed in the solution and is in contact with the solution, then the transfer of metal will take place. So this is a magnified view of a complex geometry part. The distances here are really microscopic, but you can see from the picture on your left how uniformly electroless nickel has applied itself to the surface of the part. Whereas you can see electroplating, due to the currents that are generated inside the bath and on the part, will want to accumulate in certain places. You know, electroplating loves sharp corners, and then you can see how non-uniform the plating has been applied. So electroless nickel makes it really ideal for application on complex geometries, such as really highly engineered parts. So, apologies, I've skipped a slide. So, to prove a point, we have been plating for several years now helicopter landing grids for surface ship systems for our customers. And you can see for this picture, this is a very large plate. It's roughly the size of a helicopter. And this one in particular has over 1,000 stanchion holes, which need to be plated all over. The requirements obviously have to adhere to strict Ministry of Defense specifications. So not many people can do this, and we've been doing it successfully for many years. The geometry of this part is really complex, lots of corners, lots of nooks and crannies. EMP is the ideal application for it. It's a mission critical application, and our customers want to have a plating that give them a fit and forget guarantee. We also carry out a process called diffuse nickel plating, which is where by heat treating the nickel plating, we create an interdiffusion layer. So you can see in this picture, on the right-hand side, we have our base metal. In the middle, we have the interdiffusion layer I was describing, and on the left, we have the external nickel plating. So by interdiffusing nickel into the substrate, we create a molecular structure that, as you can see, is very compact and becomes a really strong barrier to corrosion resistance, pushing it even further than that of nickel plating as plated. So this is very helpful for our customers who manufacture subsea and fittings. Imagine these as the ends of your shower hose, but on a very large scale, and these flexible connections connect the oil platforms to ships or the oil platforms to onshore stations. So these parts are obviously work under the seabed for many years, and by diffusing the nickel, our customers can give their customers a 30-year subsea guarantee. Also, after the Gulf of Mexico disaster a few years back, there's an extensive level of testing that is required on these parts to prevent, to guarantee from sort of failures in the field, and we can offer those testings from our side. Combined together, the customers we serve have over 80% of the market share worldwide of flexible pipes and subsea and fittings. Another process we use for electroless nickel is to mix it with other components and create composites that will address a particular feature or a particular requirement. And the most popular is the inclusion in the plating bath of PTFE, or as people know it, Teflon. So once again, from this microscope picture, you can see a base metal at the bottom. The band in the middle is the electroless nickel itself, and the band at the top is the mix of electroless nickel and PTFE. The PTFE is the dark dots that you can see in this picture. So by adding Teflon, as you can imagine, we increase the lubricity of the parts for parts that they need to have such a feature, or for parts that need to guarantee a smooth release even after many years in operation. So an anti-galling performance. Just as a small aside, we're also experimenting with other composites at CBE, nanoparticles in particular, nanoparticles of diamond, and nanoparticles of ceramic, Again, these are aimed at addressing particular requirements such as even further increase in hardness or increase in wear resistance. So going back to the PTFE composites, this is another case study. Our customers manufacture log slitting blades. So these are big discs that cut paper fundamentally. Amongst the paper that they cut is also toilet paper. So last year they were very busy when people rushed to stockpile, shall we call it. So these are blades that operate at incredibly high speeds, and the paper that has a component of glue creates really a difficult environment for these blades to operate in. And the issue our customers have is obviously jams and the downtime that may create. So by applying Electroless nickel plating and PTFE, you can notice how the blade is a little bit darker than a shiny metal component. We can guarantee an increased lubricity, less jams on the field, and less slitting downtimes for our customer. So to bring you all together, at CBE, we do Electroless nickel plating, but we also do all the capabilities that I described before, precision engineering, gear cutting, metal testing, etc. So the one supply chain brought under one location allows us to really provide our customers with turnkey solutions where we can seek to procure castings or forgings or raw materials. We can machine them in-house. We can plate them as the customer requires. We can carry out heat treatments to improve the performance of the plating. And we can provide our customers with a full complement of tests. In this case, our customer requires valve bodies in high volumes and very, very low margins. And by bringing together all these capabilities under one roof, we can provide them with a finished component with a reduced time to market and obviously reduced costs. So that is the end of my presentation. So I'll be happy to take any questions at this point if anybody has any.
Any questions, guys?
Yeah, I have one. Would we be able to send you an inquiry for gear protection?
Absolutely, Bill.
Okay.
Yes, indeed. Yeah.
And can you compete against Germans?
We're going to try our very best.
Okay.
We've done in the past. The one thing for something I haven't mentioned actually is that we have, as far as we know, the largest plating tanks in Europe, certainly in Europe, probably even further afield. So in 2020, we received some drilling mandrels, for oil exploration. They were flown into us from Texas. We have received some titanium melting copper rods from Germany. So yes, I would say that we ought to be able to compete with Germany.
Good.
Any other questions?
Yeah, I've got a question if you don't mind. Yeah.
Go on, Duncan.
Go ahead, Duncan.
Yeah, we sort of provide the base product for a lot of machine knife industries.
Yeah.
But I mean, the food processing knives.
Yeah.
Would that coating be advantageous to the general Teflon coatings that's on the market at the moment?
It would be for the reasons I described. So food processing can obviously it can actually be a lot harsher on the base metal than people assume. Orange juice, for example, is really quite terrible for metal. Really quite benign for humans, but nasty for metals. So indeed, we can work with you in determining what the best a combination of EMP and phosphorus or EMP and composites would be to protect your components in that environment.
Yeah, that's interesting. Yeah, I'll discuss that with some of the guys who manufacture the finished product. Yeah, nice one.
Thank you very much. Emma?
After the process, Fabio, of
Yeah.
plating, how do you dry the components?
We have two general ways of doing it. One is we have dryers, so we have sort of cabinets that effectively, you know, hair dry like a hair dryer, the parts. But there's a, you know, not 2 days are the same, but there's a vast majority of parts requires heat treatment after plating to consolidate the hardness, for example, or diffuse the interlayer. So, you know, it's one of two ways. What we don't want to do is obviously leave the parts to get stained.
Yeah.
Although EMP is not a cosmetic process, it's a very functional process, but, you know, we want our parts to look nice and shiny afterwards. So we would always dry them depending on whether we carry out further operations on them. It could be a cabinet or it could be a furnace.
Okay, thanks.
No problem.
Any other questions?
Annetta, if I may, if there are no further questions, then I'd like to pull up my slide for just a second, because Marie wanted to share with you guys she wanted to have a word with you guys about an exciting project that she's working on. Marie?
Yeah, sorry. Thank you very much, everybody, for listening. Well done, Fabio. Very good. Yes, obviously, some of you may already know that CBE Plus are partnering with the Vulcan to the Sky Trust and Workwise. We're looking to bring together a corporate initiative linking education, environmental and social programmes. It's a combined effort to bring together a range of events and activities that are an exciting opportunity to honour the past while inspiring the future. A positive challenge given the current climate. We have already 3 components of the Vulcan on site. We have the fuel tank, the engine and the wingtips, and we are hopefully expecting the cockpit soon. I think Katie will confirm at some point we're going to get that. And we have exciting plans for them all, linking education and where they're going to end up. So we'll be looking to encourage corporate involvement and support over the next few days. So please watch this space and talk to us. We know Made in Yorkshire are linking up with the guys, and we've got some exciting projects with the Made Futures event. So we'll look forward to telling you more about the story, but there's quite a bit going off. So thank you very much.
Thank you, Marie.